Okay, hello everyone. So welcome to season 13 in the Informatic Logic class. So we will discuss what recursions for these lessons. So what is recursions? So recursion is a technique in programming where a function is called back by itself. Okay, so a function that calls itself is called a recursive functions. So recursions allows breaking complex problem into the simpler sub problems. And this is a recursion advantage and disadvantage. And advantage allows solving complex problem into a simpler sub problems. So it's sometimes easier to understand and implement than a non-recursive approach. Okay, so disadvantage requires repeated function calls which is can lead to high overhead and memory usage. Error in recursive function design can cause deadlocks or infinite loops. So yeah, this is number one for regression example is the factorial. The factorial a classic example of recursions. Okay, maybe you was learning and let's see the factorial is the function n is defined as the products of all positive integer from 1 to n. Okay, so the notations for factorial is like this and in this symbol. Okay, and we have the for example n multiple n minus 1 and multiple n minus 2 multiple n minus 3 and so on. Okay, so until the ones. For example, we have factorial 5. Okay, so factorial 5 is equal 5 equal 4 4 equal 3 equal 2 and equal 1. So 5 4 3 2 1. Okay, so we have the 5 factorial. We just factorial the all numbers here, and the equal is 1020. Okay, so like that. So this is an example for the Python factorial. So yeah, we have the function factorials, and we have the argument ends, and we have the logic here, the conditions. If n equals 0 or n equal 1, so we will return 1. Okay, so why? Because n equals 0, we if we have the factorial 0, it will be 1. Okay, and we have the factorial 1, it will be 1. Okay, and else if factorial 2 factorial 3, we return n multiple factorial n minus 1. Okay, so this example, for example, I put the 5. Okay, 5 factorial. There is we can make a variable result and factorial numbers. Okay, it's factorial 5 and we print it. Okay, so the next one is recursions. Example is Fibonacci sequence. The Fibonacci sequence is a sequence of number where each subsequent number is the sum of the two previous numbers. For example, for notation is Fibonacci n. Okay, so f n minus 1 plus f n minus 2. So the example is we can initiate with a 0 1 first. Okay, the 0 ones is, sorry, let's see, the pen. So we should be the initiants to 0 and 1s. Okay, so after that we can put 0 plus 1. Okay, 0 plus 1 is will be 1. Okay, so 1 plus 1 is will be 2. Okay, so the next is equal from two numbers before. Okay, for example, Next is this is 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is what? Okay, so it will be 21, right? This will be 21. So we can see this. We have 1 2 3 4 5 6 7 8 9. Okay, so we have the 9 Fibonacci. So the number of Fibonacci, for example, 4 is will be equal to, okay, so you can um, numbers 1 2 3 4. Okay, so that's for example of Fibonacci. This example of Python or Fibonacci. We have the Fibonacci. uh Sorry, I have the Fibonacci here. Okay, for n, if n equal greater less than equal 1 equal 0, it will be return input should be a positive number. Okay, the lf and equal 1, it will be return 0. Lf and equal 2, it will be return 1. Okay, so else return Fibonacci and mean 1 plus Fibonacci and mean 2. Okay, for example, we have the number 7, so we have the Fibonacci 7 is what? Okay, so let's see. So what's a Fibonacci from 7? So if let's see, if 0, we can return anything, okay, because we should be have the positive number. Okay, for n equal 1, it shall be 0 equal. So we have 1 0 1s for the initiates. Okay, the equal 1 is shall be 0, right? Okay, for the Fibonacci 1, and Fibonacci 2 is shall be 1 for equation. Okay, for the else, yeah, Fibonacci and minus 1 for plus Fibonacci and minus 2. Okay, something like that. Okay, so next is recursion as a finding exponents. So you familiar with the exponents before. This recursion can be used to calculate the power of numbers. For example, the exponential xn is defined as x exponent n. Okay, notation it's like this, yeah, it's like xn. Okay, pangkat ya, is equal x multiple x and until n times. For example, we have 2 exponentially so equal, yeah, you know, like how this work, it will be 8. Okay, this simple for the finding exponent. This example for recursions. Okay, so recursions we will back is how you solve the problem with the soup. Okay, with the soup problems, let's see this. Okay, is solving complex problems so into the simple sub problems. Okay, so we can use this if you have the complex numbers and you can put a simple number like that. Okay, this for exponents. Okay, this is for exponents, you can put there. And this is suggestion for using recursion. Number 1 is recursion when a problem requires iterative solvings. What mean iterative solving is you should be know about the iteratives. Okay, like 1 2 3 4 and so on. Make sure there is a clear basis or termination condition to avoid an infinite loop. Okay, if this infinite loop, you should be make sure there is clear basis of termination. So you should be know when we will stop it the code. Okay, or stop it the code like that. Okay, so pay attention to memory usage and execution time when using recursions. Check and test carefully to ensure correctness and efficiency to recursive code. Okay, okay, this the X segments. What is a factorial of 4? Find the factorial of 6, and you can use the code given at least to calculate the factorials each number in the problem. Okay, since you the code, and this is for the Fibonacci sequence. You can put again into the numbers. Okay, thank you very much for today.